In this tutorial, you will learn how to do programmatic SEO with Next.js. Programmatic SEO is a strategy where we generate hundreds or even thousands of search engine optimized pages so that people can actually find you in Google. With classic SEO, you write blog posts or articles yourself, or you hire someone to do it, so it's either expensive or it takes a lot of time. Classic SEO is important, but sometimes you can take your existing data and you can just plug it into a template 1,000 times and this way target different long tail keywords. I will show you how exactly this looks in a moment. I personally had success with this strategy in my past project, so now I wanna show you how to do the same. Welcome to Coding and Flow. I'm Florian Walter and I make web dev tutorials that cut the fluff and get straight to the point. So subscribe now if you wanna make your developer life easier. Let's take a look at some examples what programmatic SEO actually is. So if I search for sushi places near me, there we go, I just doxed myself. Then somewhere here at the top we find a search result by Yelp, which is a directory of different restaurants. So now it plugged in my search query into the search field and my address into the address field, and it shows me the top 10 sushi bars in my city. And Yelp has a page for pretty much every combination of meal type and location. So if we search for steakhouse in New York, for example, then again we find Yelp somewhere here at the top with the top 10 best steakhouses in New York. And this is very important because people don't search for Restaurant Finder or Yelp or comparison website. They search for steakhouse in New York, what they want to do right now in this moment. So you want to have pages on the internet that serve these queries. But for this, we need to tell Google to index all these different combinations, which we can do by generating a sitemap and then submitting it to the Google Search Console, which you will learn in this tutorial. There are countless examples for this. If I search for Chicago homes for sale, then you will find Zillow, and you will also find it for a lot of different combinations of homes to sell. Another example is Canva. If I search, for example, for course certificate template or some other kind of design template, then you will often find Canva in the top results with the different templates listed here. And depending on your type of website, you might be able to create similar page templates and then plug your data in there to target different long tail keywords. Next.js is great for programmatic SEO. First of all, because it's server-side rendered, so search engine crawlers can actually find the data on your website. Second, we can set up dynamic routes to target many different keywords at once without having to set up each page manually. Third, we can cache our pages so that they load super fast, and we can use incremental static regeneration to still refresh these cached pages from time to time. How often we decide. How often do we want to have fresh data versus serving a fast cached page to the user. But more on that in this tutorial. I will teach you how to use your existing data to generate statically cached search engine optimized pages. Then we will generate a sitemap that automatically lists all of these pages, no matter if we have 50 or 500 or 5,000. We don't have to enter them manually, they are all added automatically. And lastly, I will show you how to submit your sitemap to Google so that your pages actually get indexed and then people can find it in Google search. For this, I will provide a little starting project that you can download and follow along, or you can use your own existing project and just apply what you learn here directly in there. Alright, let's start. Okay, if you want to download the starting code, I will put a link to the GitHub repository into the video description. It's called Next.js Programmatic SEO, and there will be two branches. One is called starting point, that's the code that we start with, and then there will be a branch with the final result after we implemented all the programmatic SEO code. You can download the code onto your computer and then you have to open it in VS Code, open the command line and run npm install. And we have to add this -- legacy -peer -steps flag, because right now Next.js 15 requires this compatibility flag. So run this command to install the packages and then this project should work. And this is how the project looks. It's basically a simple Yelp clone, but all the data is stored locally. There is no database in the backend. This is just hard-coded. And here we can search for different restaurants, for example, sushi bars. and then we can select a location. We only have these 3 locations available because I didn't want to implement a real location search. This is just dummy data, right? In a real app, you can search for all kinds of different locations. Here we have these 3 options. So for example, we want to search for sushi bars in Miami. Then we click search. It loads for a moment. This loading delay is also artificial. I added it to the code to pretend that we are loading data from the database. And then we get these 2 results, and the search query and the location are also in the URL, so we can refresh the page and we see the same data again, and the search is already pre-filled. Let's try dinner in Chicago. And again, we find 7 results with different dinner options in Chicago. Again, the data is hard-coded. It's contained in this restaurants.ts file in the data folder. Here's an array with all the different options and locations. And then we have a function at the bottom to search through restaurants. Again, I have this artificial delay of 1.5 seconds in here to pretend that we are fetching data from the database and some other functions that we need later. So this is how we search for restaurants on our website. Yeah, and the images are coming from Unsplash, by the way. Unsplash.com. If these images don't work anymore in the future, then they probably took them down. Then you can just ignore it or replace them for new images here in this image field in this array. Also, if I don't enter a location in my search, so if I remove this and just search for dinner, for example, it will automatically use the first location, which is San Francisco. In a real app, like Yelp does it, for example, it automatically uses your location if you don't enter one. So in a real website, this is probably how it would work, but here I just fall back to the first location in my list, which is San Francisco. Okay, but now the problem is that these different combinations of search queries and locations don't automatically show up in Google. The only page that shows up in Google is this search page basically, but no one searches for a restaurant finder. No one says, oh, I want to eat sushi today, let me Google for a restaurant finder first. They search for sushi in XYZ right array. But in order to have these different search queries and locations show up in Google, we have to tell Google about them by adding them to a sitemap. Now we could either add this page here directly into the sitemap and add all these different combinations of the query params in the URL, but we can optimize this by creating a dedicated page instead. First of all, this page here is not cached. So every time we run a search, it takes 1.5 seconds to fetch the latest data. It would be better if we cached these pages in advance so they open instantly. Second, these URL search params here after the question mark, the query and the location are not optimal for SEO because it looks like a search, but users and also the Google crawler generally prefer dedicated pages. So it would be better if instead we had something like this, /Miami/sushi. And then see our search results for sushi bars in Miami, because this looks like a dedicated page that we set up for this particular purpose. We can do this in Next.js very easily. Third, we can optimize our page structure a little bit. We can give it a better H1 headline, because this is important for SEO, and we can create a different layout that might be better for the search results. So first you have to think about what keywords you want to target in search. And programmatic SEO works best with long-tail keywords. Long-tail keywords are very specific search queries that are only interesting for a few people, but you can serve 1,000 different versions of them to multiply their effect. For example, when I searched for sushi bars in Erfurt, this was a long-tail keyword because it's only interesting to people who live in Erfurt and who want to eat sushi right now. For a site like a restaurant finder, this is exactly the long-tail keyword we want to target. We want to have pages that say top 10 sushi bars in Erfurt or top 10 steakhouses in Miami. But for your website, this is probably different. If you have different kinds of data, you have to think about what keywords you want to target. And then we create a page template to target these user queries. And Next.js is really great for this. So if you will use my example project, we create a new page in SRC in the app folder here. We right click on app. And in here we put dynamic URL params so that we can replace these URLs for different keywords later. For this we put them into square brackets, like this. The first one will say location. Then we make a slash to create another folder in here. The second one is called Q, that's the query. slash, and in here we put a page.tsx. What this does is it creates a URL structure like this with slash location slash the query that we are searching for. But we can type anything in here and we will then receive these values in our page and then decide what data we need to fetch. This way we only have to set up this page once, but we can generate hundreds or thousands of different pages with different combinations of location and query. This is exactly what we want for programmatic SEO. Okay, let's set up this page, and this is just standard Next.js code. Export default, we make this an async function so that we can fetch data in here. And you can call this component whatever you want. I usually just call this page. This also needs props because in the props are the location and the search query that we pass in the URL. Since we use TypeScript, we create an interface called page props. In here are the params, and they have to be called params so that we can find these values in there. There are also search params. Those are these URL search parameters that you saw here. But if we have them in the URL like this, then they are called params. Again, this is Next.js basics. There has been a change in Next.js 15 that we have to get these params and search params asynchronously. This means they are wrapped into a promise now. So we have to declare the type like this, angle brackets, curly braces. In here we find these two values. So we have to spell them the same as we used in the path. The location, which is a string, and Q, the query, which is also a string. And then we can find these params here in the page by receiving the page props. Then we create a const where we destructure Q and location, and we want to get them out of the params, which we do by awaiting the params. Again, because they are wrapped into a promise now. This is a new change in Next.js, but it doesn't really make anything more difficult because we can just get them directly in a server component, which we are doing here. But we will have empty spaces in our query and also in the location. And by default, they are URL encoded, so we have to decode them. We create a const q decoded. We call decode URI component, which is just a default function available in JavaScript. And here we pass Q. If you don't know what URL encoding is, you can see it here. This text says Miami, space FL. But in a URL we can't use spaces or commas, instead we have to escape them. This is a comma and this plus here is a space. And this is also how we receive this value here in our page. But to run our search, we need the decoded version, where we turn the spaces back into spaces and the special characters back into special characters. So we also create a location decoded, because this is also coming from the URL. And here we decode the location that we receive. And then we can use this data to fetch the restaurants from our quote-unquote database. But of course here, we just have our fake function that gets the data directly from our array. In a real app, this would fetch from a database, but for the purpose of this tutorial, this is the same. Here we pass our decoded values, the query and the location. It's important that we use the decoded values, otherwise we have these special characters in here and the search results will not match. Then we use this data to render our page as usual. So we put a div in here. And on this page, I want to put the same search header that we have on our search page and the front page, because this way, when a user gets to our landing page, they can jump directly into the main feature of our app, which is the search. So you want to have the search available on your landing page or whatever main feature you have on your website. The header is contained in this header component. I put this into a separate component so that we can reuse it. In here are the input fields, the location search, and when we submit this, we get redirected to a /search, where we then execute the search. And to it, we can pass the query and the location that we get from the URL, again the decoded versions. This way we pre-fill these input fields here. So if we later get to a Miami dinner, then these input fields will already be pre-filled which is just a better user experience. And for this, the header takes these values as input and it uses them as the default values for these input fields here. I already set this up. So we do the same for the location. Location decoded and close this. Let's save the code for now and let's open one of these pages. You can enter them like this into the URL. So localhost / and then you just type in the location exactly like you see it in the search, with a comma and with a space in here. And then another / and then the search query, for example dinner or sushi. Later we will have these different pages in our sitemap and we can open them from there, but for now we have to enter them manually. So if we type this in, for example, this gets automatically URL encoded, but we get on our new page. Right now we only see the header and the search query and the location are filled in this header, which is what we want. But now we don't use our search params anymore, we use this new URL path. Below the header, we put the main tag of the page and I want to style it with some Tailwind classes, container, mx auto, space y8, a horizontal padding of 4 and a vertical padding of 8, but you can style this however you want. This is just an example. Let's type in main just for a moment to see it on the screen. There it is. As I explained earlier, we could set up a dedicated layout for these landing pages, but for simplicity and to not make this tutorial too long, I will just use the same cards that we already have in our main search here. I will use the same cards for our new page, but we will give the page an optimized headline. So in this main tag here, we put an H1 headline, and headlines are really important for SEO. They should tell the search engine and also users what this page is about. So we style this with text center, text 3XL and font bold. And this headline should say top, then the number of results, for example top 10 sushi bars near Miami. So we fill this headline with the data that we get from our URL and from our search results. So here we write top, then in curly braces we write results.length, because we don't know in advance how many results we get. Might be 10, might be 3. Then we want to show the query that we searched for, the decoded version, and then near or in, doesn't really matter, location decoded. And when we save this, we will see top 7, because we got 7 results, dinner near Chicago. Again, a good headline is important for SEO. And below this headline, I want to put a grid inside a div that shows the different results. So we style this div with grid calls 1 on small screens. At the MD breakpoint, we set grid calls to 2. Just follow along. At the LG breakpoints, so large screens, we set grid calls to 3. And we also add a gap of 6 between the different items. Okay, this creates a div in which we can render our search results. Curly braces, results.map. We get each restaurant and we want to render a restaurant item, which we also used on the search page. I already prepared this. For the key, we use the restaurant ID, and for the restaurant data, we use the restaurant of our map call here, of course. By the way, I also set up prettier in this project, so if you press the reformat shortcut, then your code should look nice again. And here are our 7 results on this landing page. Now this search function here takes 1.5 seconds to load, because again I want to pretend that we fetch data from our database. So if we refresh the page, it takes this 1.5 seconds. But we don't need to add a loading indicator here like we have on our search page, because we will cache these pages at compile time later. So when we later open them on our actual website on the internet, then we won't have this 1.5 second delay anymore, because we render these pages in advance, we search these restaurants in advance, and then we will serve the cached page to the user. But more on that in a moment. Before we take care of caching, I want to improve the page title because this still just says restaurant finder. But again, for Google, it's better if it has a very descriptive title. For one, this is better for the search engine crawler, but also for the users, because this up here is what they see in the search results. And they shouldn't see restaurant finder, they should see top 7 dinner near Chicago. To set the page title dynamically from our data here, from the location and the query, we use the generateMetadata function. Again, those are Next.js basics. Export async function with this exact name, generateMetadata in camel case. Make sure to spell this correctly. This will return a promise because it's an async function. And in here is the metadata, which is an import from Next. This way we get autocomplete here in our return value. And this function receives the same params as the page itself, which contain the query and the location, which we want to get out of the params. So we have to do these 3 steps again. We also have to decode these values again, because again they are URL encoded inside the params. And then we need to fetch our restaurants again, because we need to know how many results we get, because I want to put this number into the title. And we can't share data between the page and generateMetadata. We can't fetch this somewhere else and pass it in both places. We have to fetch this 2 times. But we can cache the value, and this is how you do it in Next.js. Just follow along. So here above generateMetadata, we create a const which we call getRestaurants. We assign it to cache, which is an import from React. Make sure to add the correct import. And into this we wrap the search restaurants function. Then instead of search restaurants here in our page, we call get restaurants. And then we do the same in generateMetadata, get restaurants. We call this cached function here. This is a pattern you do in Next.js over and over again, because again you can't share data between the page and generateMetadata. You have to fetch it in both places. But with React's cache function, we can deduplicate this request. This means when we later render this page, for example with sushi in Chicago, then search restaurants will only be called once with this combination of input, and then the returned value will be cached, and we will effectively only call our search function once. So the return value is shared in both these places. This way we make 1 request to our database instead of 2. This is what this is all about. Now it wouldn't be terrible if we remove this and call search restaurants in both places. We would make an unnecessary request, so this is not great. But since we cache these pages anyway, we would only make this request once and not every time the page is opened. But still we can save some database load by deduplicating this request with this cache function. Okay, I hope this was understandable. And from generateMetadata, we return an object, and in here we get autocomplete because we set the return type of the function with all the different metadata values that we can set. We want to set the page title. This is really important for SEO. In here we put a backtick string, which will say top, then results.length, how many results we got. Then again I want to put the decoded query in here after a space, then again near, location decoded, and then I want to make a minus, space, and then it will say updated, and here I want to show the current year. This is inspired by Yelp. They also show the current year in the title. Apparently this is good for SEO because it tells the search engine that this is updated data, right? So in here we want to render the current year, which we get by creating a new date and calling get full year parentheses on this. So when we save this and take a look at our page, we can see our new title. Top 7 dinner near Chicago, updated 2025. And next year it will say 2026 automatically. And we can also set it the description for this page, which will be shown on social media, for example. But again, the title is the most important because this is shown directly in the Google search results. This is how this page will show up in the search results. And for the description, we will say, find the best. Again, I want to put the decoded query in here, near, and again the location. Of course, you can customize this to your liking. Okay, now we have optimized the metadata for this page. The next step is to put all these different combinations into our sitemap so that Google can find them. And of course, we still want to cache this page to make it faster to load. The Google crawler doesn't enter all these different combinations of keywords and locations automatically, because then it would have to enter every possible combination, right? Google doesn't do this. It has to find your pages, either via a link, so we could put links to all our different combinations onto the front page, for example, but of course this doesn't really look good. The other way to tell the Google crawler about all our different pages is to put these URLs into the sitemap. And this is what we will do. Again, Next.js makes this very easy because we can either set up this manual sitemap where we enter each URL ourselves, or we can generate a sitemap. And this is really cool because we can fetch our data from the database and then automatically generate an entry for all these different pages. For this, we create a sitemap.ts file instead of XML, because in there we can execute TypeScript code. And this file goes directly here into the app folder with this exact name, sitemap.ts. Okay, let's set this up, and in here we will need our base URL a couple of times. So in development, the base URL is localhost 3000, but on the internet later it will be a real URL. You can put the base URL into your .env file. I already added this to the starting project, and it has this name, next public base URL. Later in production, we have to insert the production URL into the environment variables, but I will show you how to do this later. So in the sitemap file, we create a const base URL and we assign it to process.env.nextPublicBaseURL. base URL. This way we don't have to repeat this here over and over again. Then we export a default async function because we want to fetch data in here, called sitemap in all lowercase. Again, this has to be the default export, it has to be async, you have to export it, and it has to have this exact name sitemap. So make sure that this is all added here. Again, we can add the return value to get autocomplete. We have to wrap it into a promise because this is an async function. And the return type is metadata route, which is an import from next.sitemap. Okay. And now we want to generate entries in the sitemap for all our different combinations. What we will do is we will take all the different tags. So the tags are these different keywords here that we have for each restaurant, lunch, dinner, sushi bars, and so on. And then we will also take all the locations and we will combine them into the different pages where we have each combination of tag and location. Since I only added 3 locations here, we won't have that many results. But if you have 100 or 1000 locations in your app, then of course we get hundreds or thousands of different pages. But you don't have to do it like this. How you generate these different combinations of keywords depends on what kind of project you are building. For example, in one of my earlier projects, what I did was I created an array called, for example, search queries, and I entered all the different search queries that I wanted to generate pages for myself. So where you get your data from is up to you. You could also, for example, track all the user searches and then only fetch the combination of search queries that are often searched. For example, for our website here, we could track what the user is searching for, and then we see, for example, many people are searching for dinner in Chicago. So we need to fetch this information here in our sitemap and then generate our different pages, our different entries from that. But again, the simplest way, the easiest way is to just take our different locations and our different tags and combine them to all these different possible combinations. This is what we will do here. So what we do is we create a const all tags and we call await get all tags. Again, I added an artificial delay in here to pretend that we fetch these tags from the database. But of course here this is just an array, so I have to add this artificial delay. Then we also take all our locations here, which is just a normal array. So here in our sitemap function, we return an array, and this array is the sitemap. In here we put entries for all our different pages. Usually you also have other entries in here that you want your sitemap to know about. And you can put them in here just as normal objects. So you make a pair of curly braces and then we get autocomplete. For example, let's say we want to put base URL /about in here so that the search engine crawler knows about this page. We put this in here as a normal object. Then we can also set other values. The URL is the only value that is really important, but you can set when this page was last modified and so on. You can Google these different options to find out more about them. For example, we can set this to a string that says 2024 December, for example. I think this is the structure that is expected here. Or alternatively, you can pass a date object. But again, this stuff here is not so important. The main thing you care about is simply the URL, because Google can actually infer this information if it's not provided. And then we can set things like the change frequency, how often this page changes, for example, yearly. And we can set a priority, but we don't have to set these values. I just want to show you how you can add one page, in this case the about page, manually into the sitemap. You add such a JavaScript object to this array. But our landing pages work a bit differently because we don't want to enter them all one by one, right? We want to generate them automatically. So let me add a comment here, just so you remember later what this is about. Insert your other pages, and then down here we have our PSEO pages, short for Programmatic SEO. For organization, let's generate this array above and store it in a const. I'm gonna call it search landing pages. Then we take all our tags and we map them. We take each tag and we want to combine each tag with each location, right? So in here we call locations, which we import from the data folder, .map again, because this way we can combine each location with each tag. And in here we return parentheses curly braces. We want to return one of these objects for each combination. And to get autocomplete in here, we can set the type of this variable to this one here, metadata route.sitemap, because this is what is contained in this array. So we set this to metadata route.sitemap. But this creates a two-dimensional array, which looks like this, with two pairs of square brackets, because we call map on the tags and then we call map on the locations again, so we get an array of arrays. So to turn it into a flat array, we go at the closing parenthesis here and call .flat. And then the structure will look like this. It will be an array of objects. We still don't get autocomplete in here. I don't know why, but at least we will get type saved here. So we have to type this out ourselves. We set the URL. And the URL is of course this structure that we set up earlier. It should be at /location/query. So this is what we put in here. So we start of course with the base URL /, then in here we put the location from this map call, another /, and in here we put the tag of this map call. And this is how we generate all these different combinations. Comma. Again, for last modified, we don't get autocomplete. We can set whatever we want. Doesn't really matter. I'm going to set it to the current date. This is how they do it in the Next.js documentation. But I think Google will just ignore this because they recognize that this just points to today all the time. This is not really important. You can find out more about these values by just running a Google search. I just add them here for example's sake. You don't have to add them. Change frequency, I'm going to copy this just to make sure I spell this correctly. How often does this page change? More often than yearly probably, so let's say weekly here. And priority, we can set this to 1 to say that this is an important page. Okay, so now we have these different search landing pages. Now TypeScript complains because it doesn't recognize this weekly string I passed here as a valid value for the change frequency. So what we do is we cut out this type declaration here, metadata route.sitemap, return the colon, and instead we put it down here after the flat call. We write s and we cast this to this type. Then TypeScript can figure out this value here and it doesn't complain anymore. And we should also get type safety now. So if we change the key for the URL, for example, this won't compile anymore. So yeah, for some reason it's better if we put the type down here. To be honest, I'm not 100% sure why. This just seems to be a quirk of this nested map call that we have probably. TypeScript seems to have problems with this. Anyway, it doesn't really matter. The important part is that we put these pages into our sitemap, so in this array that we return here. And we have to spread them, because we don't want to put the whole array in here. We want to put each value in there one by one. So we write ... and we spread our landing pages. And now they are part of our sitemap. We save this file and then we can take a look at the sitemap. We find it under the base URL localhost 3000 /sitemap.xml, not tsxml, because this always generates an XML file. Because sitemaps have to be XML files. And now the first page is our about page that we entered manually. And then we have all the different combinations of tags and locations. Isn't this cool? Let's open one of them to see an example. Top one, we only have one result, coffee near San Francisco. But of course in a real app we would have more results than only this one. Let's open another one. Lunch in Miami, for example. When we open this page, you will notice that we have our 1.5 seconds loading delay, which is not great. It would be better if this page opened faster, and this is of course what we take care of next. To cache our pages, we have to implement generateStaticParams. This tells Next.js all the different combinations of locations and search queries that we want to render at compile time and then cache, similar to how we tell Google about our different pages in our sitemap. And we implement this function in our landing page that we created. Let's put this function above generateMetadata and maybe also above getRestaurants. Where exactly we put it doesn't matter, but for organization I want to put it here. Again, we have to export it. It's an async function with this exact name. generateStaticParams. Make sure to spell this correctly, otherwise Next.js will not recognize it. generateStaticParams in camel case. In here we basically want to do the same that we did on our sitemap. We want to take all tags and all locations and combine them to all different possible combinations of search queries. So we need a const all tags, for which again we call await, get all tags. We pretend that we fetch this from our database. And then what we want to return is basically an array of JavaScript objects with all the different combinations of location colon, blah blah, and query colon, blah blah. But we don't want to insert them all one by one, of course. We want to generate them from the tags and locations. So we return all tags.map, similar to how we did it in the sitemap file. Here we take locations, the array, and call map. And we want to return parentheses curly braces, an object with the structure I just explained. In here we want to put the location and the search query. The search query is the tag. And again we have to flatten this array, otherwise it's a two-dimensional array. But now we have a single-dimensional array that contains these objects with each location and each tag as the search query. And that's already it. By returning this array of objects, we tell Next.js that we want to render all these combinations at compile time and then cache these pages so that they open very fast. The only problem is, let's say you have thousands of pages. So every time you compile your project, you fetch the data for all these thousands of pages to render them. And this will happen every time we compile our project. So every time we deploy an update. Of course, with our 40 or 50 pages that we have in here, this is not really a big deal. But with thousands of pages, it is. So what we can do is we can only return a subset of the pages that we want to render. For example, by limiting the number of tags that we fetch. To get all tags, we can pass a limit number. Again, this uses our fake data, but in a database, you can also limit the number of values we want to return. And we could say we want to limit this to only 10 results. So now we have 10 tags and 3 locations, which are 30 results in total. So we only render these 30 pages at compile time. Now what happens to the other combinations that we don't render in advance? They will be rendered the first time a user opens the page. So if a user goes to a page that we have not yet rendered and cached, then Next.js will go ahead and fetch the data, render the page, and then it will cache it. So the second user and all users after that will get the cached page that is really fast. Only the first user will get the slow page, and I think this is a good trade-off. We could also take this a step further and just return an empty array here. Then we render all these pages when they are first accessed. But it's important that you return this empty array. If we remove this altogether, then none of these pages will be cached, no matter how often they are opened. Only if we return an array here, and it can be an empty array, then we cache these pages the first time a user opens them. I hope this is understandable. In our case, since we don't have so many pages, I will remove the limit here and render all of them at compile time, so they are cached immediately. But I will leave a comment here as a reminder. So we add this limit 10, I comment this out, and here I write, if you have very many pages, you can only render a subset at compile time. The rest will be rendered and cached at first access. I think this is understandable. There is one more cool thing we can do. So by default, these pages get fetched and rendered when we build the project, right? And then the next time we build the project, they get updated again. But maybe we say we want to have them updated once a day or once a month or once every couple of hours. But between this time, we want to serve the cached version. And again, you can do this very easily in Next.js. We can export another value. Again, where we put it doesn't really matter, but we have to export a const with this exact name, revalidate. And here we can define the number of seconds after which we want to re-render this page. So when a user accesses the page after this time has passed, then it will fetch the data again. It will take 1.5 seconds. It will render the page and then it will cache it for the next period that we set for revalidate. And I want to set this to 24 hours just as an example. So I set this to 86,400 seconds, which is 24 hours. Now I tried to write this as a multiplication like this, 24 times 60 minutes times 60 hours. This is of course more readable, but for some reason this didn't compile. This threw an error. I guess this is a bug right now in Next.js 15. I'm sure they will fix this in the future because this used to work, but right now we have to write it like this. And I'm also gonna add a comment. Refresh cached pages once every 24 hours. This way we get the best of both worlds. We have static caching, so our pages load fast, but we still get relatively fresh data because once every 24 hours, this page is re-rendered with the latest data. Of course, we can also set this to a smaller value to get more frequent updates. It's important to note that this will only work when we compile the project, not in development. So if you have npm run dev running, and you open your different pages, it will still take this 1.5 seconds to load the page. This will only cache when we compile the project, and we can do this in development by stopping our run dev execution, and we run npm run build instead, which compiles the project. This takes like a minute or so. Here we can also see the number of pages it has pre-rendered, 43, for our different combinations and search queries, and then we run npm start. And now we run our compiled project, which will be much faster. Let's refresh the page. And now when we open a page in our sitemap, they will open instantly. Boom. There is no loading delay. Isn't this cool? Because now all these pages are cached, so they open instantly. And this is great for SEO because a fast page is a good signal to Google and other search engines. Okay, this is an empty page, but in the real app, of course, we will have more data. Perfect. Next, we will deploy our project and then submit our sitemap to Google so that they can actually crawl and find these different pages. The easiest way to deploy a Next.js project is to do it on Vercel because they are the creators of Next.js. So create an account on vercel.com. You can use a free hobby account. But if you want to get your website into Google, you will need to buy a custom domain because you can't use these free Vercel domains in your Google Search Console. And you probably also don't want to use a Vercel URL for a real website. So in order to deploy our project, we first need to push it to GitHub. You can do this directly in VS Code. Here in the source control tab, you can push this to a GitHub repository. I've already done this. Then we go back to Vercel. We have to make sure that our Vercel account is connected to our GitHub account. You can change this in the settings. And then we can simply click on Add New Project. And this will automatically fetch the repositories from our GitHub account. Really cool. So we import our project. This automatically recognizes this as a Next.js project. If you use my sample code, you have to change the install command because again we need to add this legacy peer depth flag, otherwise this will not work. So we set this to npm install legacy -peer -depth. Make sure to spell this correctly. And we need one environment variable. Remember, in the end file, we have the base URL, and we also have to enter it here. Otherwise, the links in our sitemap will not be correct. Here, of course, we have to use the production URL. This is the domain you bought. If you haven't bought a domain, then you can't submit your page to the Google Search Console. I have bought a domain, which is called https://codingandflow-sample.com. This is my production base URL. And when we have set this, we can deploy this project. And this compiles our project, which by the way also generates our cached pages like we did earlier when we executed run build. And then after a minute or so, this will be finished and we can open our website. There we go. And the cool thing about Vercel is that we can just push our latest changes to the main branch and they will automatically be deployed. And then a minute later, we will see these changes. And we also get this free URL here. But again, we can't use this URL in the Google Search Console. But yeah, let's see if the page still works. Sushi in Miami. We see our results. Let's see if we can find the sitemap. Sitemap.xml. There it is. Let's see if we can open our pages. We actually can, but the base URL points to coding and flow samples. So what I'm going to do is I'm going to copy this just for a moment and replace this part here. And then it should work. There we go. And it opened instantly. So now I want to connect this URL I bought. codingandflow-sample.com. I bought it on Namecheap, but where you bought it doesn't matter. We can connect it to our Vercel deployment in the settings of this project. So we are still inside this project. We go into the settings and here we click on domains. And here I add the domain that I bought without the HTTPS, just the domain itself, which is this one here, codingandflow-sample.com. Then we click on add domain. Here we keep the recommended settings, click on add again. And then we have to configure this properly. I already did this earlier, but of course I want to show you how to do it. So I removed these entries for a moment and this is what you should see. So here you see these different records that you have to add to your domain provider. Again, in my case, this is Namecheap, but it doesn't matter where you bought your domain, you can do this everywhere. So here I have this sample domain. I can click on manage And we want to find the DNS settings. Again, this option should be available no matter where you bought your domain. You want to find the DNS settings, because there we can add these records that we get here on Vercel. So here we have host records and we can add a new record. And Vercel tells us which ones we have to add. We have to add an A record with this name and this value. So let's do this. A record, host is add, value is this IP address. We add it here, and it takes a moment before these changes come into effect. Once they are active, this will automatically refresh and show this in green instead of red. But we have to add one more, this CNAME record here, with the name www, and this is the value, but I think we actually don't need the dot at the end. I'm not sure, you have to try this out. So we add another record, CNAME this time, www, and here we add this value. And we add this record as well, and we keep this page open because later in the Google Search Console we have to add another record here for the verification of our domain. So again, this will take a moment before these changes come into effect. Add all these different records it tells you about here, and wait until this says valid configuration for all of them. Okay, I had to wait about 1 minute and now everything works, and it seems that we do need this dot here at the end. When I pasted this value, it added the dot automatically, so apparently we do need it. I was wrong. So enter this here, and when this says all valid, then our domain should be connected, which means that we can now go to codingandflowsample.com and we find our website. Isn't this cool? And now the entries in our sitemap should also point to the correct pages. Codingandflowsample.com, let's open one of them. Boom, there we go. The last step is to submit our page and our sitemap to Google so that the crawler can crawl all these different pages and index them, and then people can find them in the Google search results. To get your site into Google, go to search.google.com/search console or just Google for Google Search Console. This tool is free to use, and later you can also observe your search engine traffic here. So you will see how many people get to your website through Google search, what they are searching for, and so on. To add your website here, you have to add a new property, which you can do in this drop-down menu. Click on Add Property, and then enter your domain without the HTTPS and without www, just like this. codingandflow-sample.com in my case, but I've already added this site, so I'm gonna change the URL to a sample2 just to show you the steps again. Then we click on Continue, and then we have to add another text record to our DNS settings. I already showed you how this works. We have to add a TXT record with this value here. You can copy this key, go to your DNS settings, add a new record, type TXT, this is the host name and add symbol, and in the value you paste your token. Then you save these changes, and then it will take sometimes a few seconds, sometimes longer for this page to recognize this token, and then your site is verified, and then you basically see this screen here with all the different information. Now for the first day or two you usually see this text here because it has to process the data first, and then you see your clicks and all the other information. Next we want to submit our sitemap so that the Google crawler can see all our beautiful generated pages, and we do this here via this sitemaps menu option, and here we can submit the URL of our sitemap, which is of course https:// our URL, codingandflowsample.com in my case, /sitemap.xml, right? We can submit this sitemap. Then it should look like this. Status should say success. It tells you how many pages it discovered on the sitemap. And now the Google crawler will periodically go through the sitemap and index these pages, but the crawler has a bit of a brain of itself. Google ultimately decides what pages they index. It's not guaranteed that they index all pages. It depends on different factors. For example, how useful these pages are. So you want to make sure that you put useful information on your generated pages. Now there is a little trick we can do to speed up this process. I've done this in my earlier projects when I was very impatient. I took some URLs that were especially important to me because, for example, they have a lot of traffic. Let's copy this one here. Then we can enter them up here in this inspect URL field, press enter, and then we can tell the Google crawler to index this page via this request indexing button. This will speed up the process because it triggers the crawler to index this page right away, and this is faster in my experience than waiting for it to crawl the whole sitemap. But it's not necessary. Eventually the crawler will crawl your sitemap. Now we have successfully requested indexing for this URL. You can only do this for around 10 pages or so per day, then you will get an error message, then you have to wait a day. But again, this is a bit faster. And to see which of your pages actually show up in Google, you can use this search pattern. Type into Google site : and then your URL. And then you will see all the pages in Google search of your website that are indexed there. Right now, only our base URL is indexed, because crawling the sitemap takes a while, but if we wait a few days, then some of our pages here will be indexed in Google search, and then a few days later, more of our pages, if everything goes well. I hope you liked this tutorial about programmatic SEO in Next.js. If you want me to do this for your website, then you can contact me at florian@codingandflow.com and I can implement this for you. Apart from that, I also want to mention that I'm working on a brand new Next.js course. It's not finished yet, but if you want to stay up to date, you can join my free email newsletter, which is a good idea anyway, because to this newsletter I send Next.js tips that I don't always post anywhere else. Go to codingandflow.com/newsletter to join it and stay up to date. Also subscribe to the channel if you haven't yet, so you don't miss any future videos, and like the video if it was helpful. Have a nice rest of the day, happy coding, take care.